teman-teman sekarang lagi pada sibuk ya kayaknya, ada yang mau ujian, mendekati ujian akhir semester juga gitu. Nah, hari ini mungkin teman-teman bisa refresh sedikit sekalian menambah materi terkait dengan research metodologi. Saya yakin kita semua relate ya. Dari daftar hadir saya juga lihat ada yang dari SAPPK, ada Pak dosennya juga sudah hadir di sini, Pak Doni Kurniawan, terima kasih Pak sudah hadir. Gitu. Ada yang dari S3 dan juga ada dari S2, ada alumni juga sepertinya. Terima kasih Mas Murni sudah datang. Baik teman-teman, akan kita mulai. Welcome to the very first GRAD TALK series, a new discussion series initiated by Doctoral Program in Visual Art and Design, Faculty of Art and Design ITB. We are excited to begin this series today and we look forward to many more inspiring talks and discussion in the future. So it is not the only talks, we will look forward for many great talks in the next time. Yeah, so please waiting for the next announcement. First of all, I would like to warmly welcome all the audience here. We are also honored by the presence of Professor Chakrabarti here. Thank you for that. And it is a pleasure to welcome all participants today in today's graduate talk titled Introduction to Methodologies for Design and Design Research. Before we begin, my name is Hanifah. I'm the first year of the doctoral student under the supervisor of Pak Denny. So before we begin, let me briefly introduce our speaker for today. So, Professor Amaresh Chakrabarti, as Pak Denny mentioned before, originally background from the mechanical engineering, and now he is a senior professor and chair of the Department of Design and Manufacturing at the Indian Institute of Science in Bangalore, India. It is one of the leading research institutions in India. So he earned his degree, Bachelor of Mechanical Engineering, and also continue his master in Mechanical System Design, and later received his PhD in Engineering Design from the University of Cambridge, UK. Also before entering academia, he worked as a design engineer at Hindustan Motor, so he also experienced as a practical designer, practitioner. Hindustan Motor is one of Indian major automotive company. And later he continued his research career at the University of Cambridge as research associate and senior research associate. And today, Professor Chakrabarti is internationally recognized for his contribution to design research methodology, engineering design, sustainability, and AI in design. He is also Editor-in-Chief of AI EDAM journal, published by the Cambridge University Press. And he also authored and edited many influential books on design. The books is mostly about design research and engineering design with numerous publications by Springer. The book displayed here are only some of his work, and there's many more books that he already published. And so, ladies and gentlemen, please welcome Professor Chakrabarti to the stage with a warm round of applause.
Well, thank you. Salamat pagi. So it's a pleasure and an honor to be here. And my sincere thanks to Denny and his colleagues for inviting me here. I've been to Indonesia many times, but this is the longest stay that I'm going to have in Indonesia. All other stays were within 1 week, and this is going to be 15 days, so that's much longer. I'll connect in a second here. We just keep it here. Just keep it here. Yes. So what I'm going to do, I understand that it's a mixed audience. There are not only grads but also now some professors. So if I'm saying something that is very basic, please pardon me. But I thought that it's important for students to know where I'm coming from, and therefore I will even go to say what I mean by design. Okay, so allow me that latitude, and of course we'll have questions. I'm really looking forward to your questions and our discussing with you. Okay, so let me take a step back and maybe start with designers. Okay, who is a designer? I understand that this department or faculty is already blessed with various kinds of designers. So I thought we'll go back a little bit in time and see the kind of people that we might call designers. This is my first example. Does anybody know who this person was? Not that I expect. If you gave me this photograph, earlier, then I would not be able to tell. Also a very ancient person. 1693 to 1776. You can see that he did something with a clock, right? So his name is, without further ado, his name is John Harrison. He was a craftsman in England, and he solved one of the most difficult scientific problems of his time. This was the time of Isaac Newton. Okay, what was the problem? The problem was of measuring time. Now, you might wonder why. I mean, that must be pretty easy. We have solar clocks since millennia. So what was so big difficult about finding time? It turns out it's not just finding time; it's finding time on the sea. Now, the best clock of the time was a pendulum clock, right? Tick tick. The pendulum clock works perfectly fine if you have a stable surface, right? What if the surface is doing this? What happens to the pendulum? It doesn't work, right? Now, if you're on a vessel, on a ship, and you are trying to navigate the ship, which looks exactly the same in all directions, and you do not have, let's say it's an overcast sky or it's at night, and you're traveling, how would you go to a particular place? So this is where we know now we have GPS and everything, but at that time there was nothing. So people had to use a compass to say direction, and they had to then calculate the speed of their ship to figure out where they're ending in which direction. And that's how they navigated the ship. And that was the primary mode of transport between continents. There was no aircraft, right? And not everything is connected by land. So, finding longitude is a beautiful book. You should probably read if you have not, by Noah Sobel. It tells us the story of how we solve the problem of finding longitude. Longitude are those lines. If you take this as the Earth, and Earth is rotating like that, then these ones are longitude and these ones are latitude. So how do you go along the longitude? So finding time on an unstable surface was a problem. And nobody thought that it could be solved, including Newton. Okay? Galileo tried to solve it, could not solve it. So it was a really difficult problem. And who solved it? A designer, a craftsman. Okay, he was a clockmaker, and he came up with the first marine chronometer, which had a spring that will just go on doing this, tick, 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 tick. We use that in all mechanical clocks today. It's called a balance wheel, but it was not known. not invented until then. And he invented several marine chronometers. If you go to England, go to London, then I will very strongly suggest that you go across the river and go to a place called, what is that called? The GMT of G, what is it? Greenwich Mean Time. So you go to Greenwich, and there is a museum where you can see 5 different clocks that he designed, all of which worked. And the story goes that there was a huge prize, 10,000 British pounds, for solving this problem. But for many years he was not given that prize because the chief of the committee who was entrusted with giving the prize was also competing to get the prize. So the king finally took a separate session with him when he was in his 80s, and finally gave him the prize. 10,000 British pounds in 1700s is more than $1 million UK pounds today. It's a huge prize, but it was worth it. So that's my first kind of designer, and that's the crafts folks. So you see all the crafts folks in various countries, including here, you have such a rich craft tradition. They are the original designers. So that's my first kind of designer. Second kind is this gentleman, about 100 years from John Harrison, also an Englishman. And those days, of course, smoking everywhere was very fashionable. And you can see that of many things that he designed, one was a ship. So he designed a ship. What kind of ship? Lots of ships are there, we know. So what is so special about his ship? Okay, first of all, his name is Isambard Kingdom Brunel. Okay, I would like you to later on look up your Google and read about Brunel. There is a university in his name called Brunel University. And the British, I think, voted him as the best ever engineer from Britain. Ever. Okay, so Brunel, among many things, designed this beautiful bridge, okay, over Avon, one river. And those days people did not distinguish between engineering, art. See, today we talk about art and design. We talk about design and technology. There was no distinction those days. He designed everything of this, right? This particular shape that you see, it's inspired by the Egyptian temples, okay? And what he designed is not only how the bridge is going to stand, but also this undercarriage, so that somebody can go to the back, bottom, and maintain it. He also designed a way in which these little pieces, which are not little at all, they are about the size, each of those pieces are at least this much long. And they are made of pure metal, was taken from another factory to carry. How do you carry them? That's also a problem. So they looked at the entire, we talk about systems engineering today, systems thinking today. They were doing systems thinking because all aspects of this was designed by him. So my second kind of designer, engineering designer, okay? And by the way, what did he design? What was that ship? It was the first transatlantic steamship that was made from iron. And what's the big difficulty of doing that? Well, it is the first ship that could go from Britain to America without refueling of coal. It took all the coal in one go and went straight from UK to America. It was not possible those days. You have to go to another, you have to go around like that through the coastline from one place to another, get a bit more coal. Why did they do that? Because they believed that ship has to be very slim and long so that it doesn't fight with the water. He was the first one who said, it doesn't have to. I can make a big fat ship and it will still work. So that was his big invention. So anyway, I will skip the technical part of it. But basic idea is the following. When you are pushing something through water, water will resist that, right? How many people swim? Raise your hand. How many people swim? Raise your hand. Okay, many of you. So you know that to move through water, you have to really fight it. how much you fight depends on how much you have as the area. The more area, the more you have to fight. So now, when you are carrying, if you have a ship and the ship is swimming, it's the area of the ship that decides how much fight it has to do to go through it. But how do you fight? By burning coal, no? So if you can carry more coal than the amount of fight you have to do, then you will win. And it turns out the amount of coal you can carry depends on the volume of the ship. So surface area of the ship grows smaller, not as big as the volume of the ship when you make the ship bigger. Okay? So therefore, the bigger the ship, the more is the amount of volume compared to amount of area. So in fact, that ship went to US with spare coal, which means it really was well designed. Okay? So this is my second kind of designer. Third kind of designer, I think some of you will probably know. How many people are from graphic design background? Yes. So then the two of you should know it, right? So this is Saul Bass. Saul Bass was an American designer who designed all of these posters for movies that are very famous or infamous. Okay, Psycho and Graduate and so on. And also he designed all these logos. All of these logos, many of which are still used, were designed by Saul Bass. And he was also a kinetic typographer. So he came up with kinetic typography and so on. So that's my third kind of designer. So we have craft designer, engineering designer, this is form designer. Okay? And then that's another one. Okay, how many people are industrial designers? Raise your hand. Oh, you don't have any industrial designer? Well, Denny is one, right?
Interior designer.
Yes, interior designer. Okay, so anyway, those who are in industrial design would have known who this person is. He's still alive. And he designed things like this. Okay? Now, there is a purpose why these dots are there, right? So because the sound has to come out of this instrument. But of course, we could have put this dot in any which way. Its sound would still come out. But if you put it this way, then of course it looks much better. And this and so on. So, he designed many iconic industrial products for a company called Brown. His name is Dieter Rams. Has anybody heard of Dieter Rams?
Yes.
Yes. So, this is my fourth kind of designer, industrial designer. And he has these 10 good design principles which are universal. I think you can always apply them. Innovative, useful, aesthetic, understandable, unobtrusive, honest. Means what it shows is what it does. Okay? You design a bike that goes like this, but it has lines that looks like it is going to go like a very fast bike, is not honest. Right? So long-lasting, thorough in detail, environmentally friendly, involves as little design. I absolutely love the last one. Okay? Whenever possible, don't design. Okay? Leave things as they are. That's the best design. Okay, my fifth kind of designer. This, I think you will see in airports these days, right? This is a bladeless fan. So this guy challenged many of the concepts of a fan will have a blade. He said, no, let's design a fan that doesn't have a blade. Typically you have a vacuum cleaner that has a bag inside. He said, no, let's have a vacuum cleaner without a bag. And his name is James Dyson. So Dyson is a design engineer. He's not an engineering designer, he's a design engineer. Okay? Who brings in industrial design and engineering together and designs that. Okay? So this is a bagless vacuum cleaner, one of the earliest that he had designed. Okay, because then your suction becomes much less if you put a bag. If you don't put, then it's good. And so that's what it is. Many other things. And my last kind of designer, there is also a James Dyson Award. Of course, everybody knows who this is, right? No prize for guessing. I wrote my PhD thesis on one of these. Okay, it's called a Apple Mac. Okay, and it's a tiny screen, about this much. But we were so proud because whatever you could type, we could see. Earlier, you had to write a program, and then you say, okay, execute the program, then you could see what it looked like. Many of the computer scientists still do that. Okay, they use something called latex. But this is the first time you could see what you are typing directly, and that was fun. Anyway, so that's him, my sixth kind of designer, an innovator entrepreneur. Okay, he's the first one who said that complex design can be friendly. Earlier, only two colors were used, black and white, and mix of those two. He came up with all these translucent colors and so on. He spent a great deal of time in this curvature. Right? Many of you have, how many people have iPhone? Raise your hand.
Everyone.
Pretty much everyone, no? Yes. So, Samsung and Apple are fighting many battles in the legal front to decide what curvature is, who is having that curvature. Okay, so all of that thanks to Steve Jobs. Okay, so I have just given you 6 examples of who is a designer. You can see the variety, and there can be many more kinds of designers. Interior designers follow one, and so on. Okay, craft designers who looked at all aspects of the craft. Engineering designer who looked at functional aspects, like a PCB designer or a VLSI designer. Form designer who looks at specific formal aspects. Industrial designer or product designer who looked at all formal aspects, not only one formal aspect, like Dieter Rams. And then industrial design engineer who looks at both functional and formal aspects of products. And innovator entrepreneur who designs not just the product but also the entire life cycle, including the business of bringing it to the market and sustaining it in the market. Okay, so we have all kinds of designers. So I think both art and design and technology can very nicely complement each other and work with each other. And then brings the question, what is design? Now again, I think there are more definitions of design than there are designers. However, therefore it is important that I state what I mean by design. And this definition is taken from Herbert Simon, but I'll come to that in a moment. But before that, allow me a little bit of expansion from some of the pieces of work from all kinds of areas. So these are ancient Egyptian paintings. You will often see them in multiple rows, like that. And there is a reason why they are painted in this way. The primary reason is that they did not yet invent how to draw perspectives. And therefore they came up with a symbolic representation of perspective. They said, if something is at the bottom, it's closer. Something is a little further, I'll put another row there. Something is a little further, I'll put another row there. So it was a social contract. We decided we are going to use this as the way of drawing perspective. Okay, what is front, what is back, and then do it. Okay. There are many other things here. For example, you see that all the faces are sideways, right? All the feet are sideways, but all the front, the chest is front ways. All the eyes are front ways. Why? This comes from their religious belief. They believe that the person will go to heaven afterwards, and for that the body has to be preserved, and all images of the body is also part of the body. And it is the best representation of the body that has to be preserved, and they believe that chest is best represented in the front, and feet are best represented at the side, and so on. There is a reason why that was done. But I'm focusing primarily right now on the perspective. Okay, so you see that this is how they did it. Okay, and compare that with the Renaissance Italy. This is taken from Sistine Chapel. Okay, this is a depiction by Raffaello on the School of Athens, and the topic is right in the middle. So you see, this is Plato and Aristotle, and you see that one of them is raising his hand up like that. You see, like that. He's putting his finger like this, and this guy is putting his hand like this. So they are actually discussing idealism with realism grounded. Okay, that's not the point that I want to make. I want you to see that the figures here are much smaller than the figures here. Okay, the lines here, look at these lines, they are slightly at an angle. Okay, we will know when you have figured it out that there is a vanishing point against which they are drawing it. Okay, so they have figured out a more realistic law of perspectives now. Right? This is a real photograph in a trench in Second World War. You see what is happening? All the army people are reasonably similar in size, but they look smaller. And the ratio at which they look smaller is something that have been figured out by that time. Okay? So you see that there are multiple, so this is multiple, this is of course a railway line, and of course railway lines don't connect with each other. Then train will not move, but they look like that, right? Yeah. So I want you to notice that in all of these human constructions, piece of art and so on, there are always multiple goals. There is a theme that you are trying to convey. There is this level of realism you expect in these cases. Maybe there is a level of pleasantness that you want to have so that people actually look at it for long enough and so on. And some of these goals are more important than others. And also what you can achieve and so on. The third is that there are multiple ways of achieving those goals. Okay, there may be an Italian way of doing that Renaissance, or an Egyptian way of doing, and some are better than the others. And now, what is better, of course, is something that we can debate and discuss, and it varies from one domain to another. Please remember those 4 points. So you come to this one. This is from the ancient Greek architecture. This is the Tinos. And this is the one of the 4 hills in Athens, Athena, and on which the Temple of Athena was constructed. In the Greek ancient times, they were very brightly painted, but of course, time has taken away all the paints. They look very, very pristine. But that's not how the Greek temples were. Well, in the neoclassical era, people copied this style, thinking that this is the style the Greeks had, and that created another piece of architecture. But originally, they were all brightly painted. I wanted to focus on this. Look at the number of columns that are there. There's a very large number of columns. Now, it's not easy to carry stone, right? Especially on a hill. Why would anybody carry so much of stone if it's absolutely not necessary? It cannot be just because of aesthetics. And it turns out the reason why so many pillars are required is because of the material that they are using. They are using stone. And you see these little beams on the top. The one major reason lies there. So for that, let me go back a little bit. How many people are from architecture other than the professor? Who are from architecture? You are from architecture. You are from architecture. Anybody else? Okay, good. So you will, I'm sure, understand this. But when people started, if you look at the burial sites from say 10,000 years ago, whether it's in Sumer or if it's in Indus in India or Afghanistan and that area, you will see that they're basically taking a plate and this chunk of rock and putting it on 2 other rocks to create a little space underneath, and then the body is kept there, right? So that's the most common and general way of covering a space, creating a space, okay? And over a period of time, they became more refined. It's called a beam. So when you put something across, it's called a beam. The problem with the beam is that it stretches on one side and it compresses on the other side. Okay? Because if you are bending something like that, the top portion becoming slightly smaller and the bottom portion is becoming slightly bigger. So stretching and compressing at the same time. Now materials are either good at stretching or are good at compressing. They are usually not very good at both. So therefore they don't like it. So they are weak. Now if you look at a rock is, you can put as much weight on it, it will be okay. But if you try to stretch it, it will crack. So I'll come back to this slide in a second, but let's go back to this one. These blocks here are those beams, right? And these beams are stretching at the top, at the bottom, and compressing at the top. So they will crack at the middle, unless you keep them reasonably small. Now, how do you keep them reasonably small? By putting lots of columns. Now, over a period of time, when people started putting lots of columns in lines, it became a style, and we call them colonnades, a series of columns to create a space. There are many other things. I just wanted to focus on one little thing here. So, going with this story, look at this story. Okay, this material is struggling to both stretch and compress. Somebody, the Romans, came up with the idea that I can actually create something like an arch. And if I get it right, these things will only get compressed and not get tensed. Okay? So therefore, I can use this stone, no problem. They will survive for many, many thousands of years. Only problem is I have to hold it. Now I have to show it to you. Just hold on for a second. Okay. I need a piece of paper. That's good enough. Okay, so I am using this to explain to you how you can have this is called an arch. Okay? How you can have an arch, but you have to hold it sideways. So look at this. So I'm just, this is an arch, okay? Everybody sees it, no? But if I take it out, it falls. So you can create an arch and it will take only compression, but you have to hold it from the side. Okay, good. This is a very important point. You have to hold it sideways. And I'll show you how that was instrumental in creating all kinds of stuff. Okay. So if you take an arch, now you can stretch it and create a tunnel like this. Right? If you take two such arches and crisscross them, you can create a growing vault like this. And then using that growing vault, you can multiply and you can cover a large amount of space, almost flat. Okay. So suddenly, as an architect, I have a new building block with which I can create stuff. And I'll show you what it does. Oh, one more thing. I can take one of these and I can spin it and create a dome. Right? Now, look at this. Okay? So this is about 5 kilometers from Rome. Okay? One great Roman king called Caracalla, 3rd century AD, his bath, huge bath, I have been there. But of course, tops got broken, but everything is a growing vault. Entire place is covered with growing vaults. And this is Pantheon, one Roman temple in the middle of Rome. And it's one of those spinning, right? Look at the side. How thick is that? Why is this thick? Because you have to hold it from the sideways. They are using weight of the wall to hold it from the sideways. Alright? That doesn't have to be the only way. It can be any other way. There are some churches and so on where they put a metal sickle, like a chain at the bottom to hold it sideways. There's something called flying buttress. I'll show you in a second. There are many ways. This is a painting by Panini in one, that's. So when you hold it from sideways, you can actually open the top. That's the only opening in a dome here. Okay? Now, the problem is that because you are holding, the wall is heavy and it's holding. Number one, you require more material because it's heavy wall. Number two, you can't make holes there. If you make holes, what happens? It doesn't have the strength to hold it, so it will fall apart. So there is a problem. All these Romanesque buildings are both heavy and gloomy because the light doesn't come, you can't make opening, and it's heavy, right? So these are not good things. Until the Gothic architects came and they said, well, my arch doesn't have to be circular, it can be, as long as it's covered, it's okay. So I can have pointed arches. I can have arches where this distance and this distance are different and all that, right? And most importantly, they said, I don't have to use the entire wall to support it. I can use portions of the wall to support and transfer the load. Look at this, look up. Okay, you see here, what is there? There is a beam there. Can you see the beam? There is another beam here. And there is another beam here. And there is another beam which is covered there. So what is happening is that when the load is coming from the wall, it's taken by that beam, transferred to this cross beam, and that's how it is, and then it goes down this column. There is a column behind this, which takes it down to the ground. Yes. So the same idea that Gothic guys have figured out, we are still using in a different form. Okay? So this is called decomposition of function. Okay? Not everything has to function for everything. Okay? I can divide that. I can use this portion for load carrying and that portion for load carrying, and the in-between space I can make holes, no problem. And so suddenly you see where the doors are. Look at this. Where is the door? Between these two columns. This is exactly what these guys did, and I'll show you the next example. So this is Notre Dame, okay? This is Notre Dame. It's a church in the middle of Paris, and you can see River Seine here and the River Seine here. It's a little island in between in the Latin quarters, right? Look at, so this is the front of the church, right? And this is the back. Look at these lines here, these lines. What is happening? These are called flying buttresses. So they are actually supporting, okay? They are the ones that are supporting the wall so that the arch can remain as it is. Look at in between. What are you seeing? Little back things, no? What are those back things? Windows. So all the windows and doors and so on are placed between those flying buttresses. All right? This is almost, within few hundred meters of Notre Dame, another Saint-Chapelle. And you see, these are the areas that are taking the load, supporting. And in between, you can put all of these glass windows and so on. So almost wall becomes non-existent, right? Okay. So once again, I want you to remember that there are multiple goals. You have to cover space, provide air, provide light. But not all goals are equally important. Of course, without air, people will not survive, so you have to have. But it will be good to have the other ones, right? Light is good. And you can see multiple alternatives. Gothic, Greek, Roman, various others. Some are better than the others, at least in terms of how much light you can get, how little material you need to use. Okay? And now I'll come to more mundane examples from engineering. Okay? And it's a innocuous problem. How do you hold a bunch of papers together temporarily? Do you have a gem clip? That's okay. Everybody knows what a gem clip is, right? Yeah? Something looks like this. Okay. There's a huge history of gem clips or gem clip like stuff. There's a book, I think you should all read it. It's by Henry Petrosky. It's called The Evolution of Useful Things. It's a tiny book. And it's really fun to read that, how regular things got evolved over periods of time. Okay? I'll only tell you a little bit of the story of gem clip. So how do you hold a bunch of papers together? No, in the beginning they had these kind of grubby metal pieces connected with a piece of cloth, and that's what they used. So the pin was invented much later. Somewhere they figured out that one side needs to be more pointed and other side can be more thick. And there was a whole industry of how to put pins so that they don't poke into your head. Okay? But these pins will come out easily and all kinds of problems are there until in 1901 or something, a Norwegian guy invented something like a geometry clip. Not quite the same, but close to that. And then the problem was that these clips started getting flung with each other. They will get stuck to each other and so on. So there are hundreds of patents on only geometry, on how to hold papers together. These are just some examples. It's called Kona clip, and this is called a Gothic clip. I'll show you a Gothic clip. So they took the motif from Gothic architecture and applied that to a clip. Because see, when you push the clip into the paper, you want as little contact with the surface. And Gothic gives that. Of course, a round one will also give that, but it looks more interesting here. And then finally it enters there. See, there's a fundamental problem of designing clips. What's the problem? It should be very easy to put, but it should hold it very tightly. And until the point that you want to take it out, it should be very easy to take out. So how do you design something that is very easy to hold, put, and it holds it very tightly? Normally, in a clip, it's a spring. A clip is a spring. So when you want to tightly hold it, the spring has to be very stiff. But if it's a stiff spring, it's very difficult to put. If you make a light spring, it will be easy to put, but it will not hold it tightly. So there is a conflict between these two functions. And only some more complex designs are able to solve it. The regular clip cannot solve it. Which is why there are so many different patents on this. But I want you to go back to my point again. There are multiple goals. You want to push it easily, you want to hold it tightly, you want to take it out easily. Some are more important. Hold it tightly is most important. Right? Multiple alternatives. There are like hundreds of different variants. And some are better. Difficult to say. Some are better in some aspects. Yeah. We should break now? Okay. We are almost in the place to break. So all of these have been designed, okay? They have multiple goals, and some are better, more important, and they have multiple alternatives, and some are usually better than others. So what I want to show you is that design is actually fundamental. Design is not architecture, design is not engineering, design is not art. It is something that drives all of them. And that is fundamental. So what is that design? And this is where my last slide before you get your food comes. And that's about Herbert Simon's definition. Okay? It always starts with something that you are not happy with. Or you can be happier with something else. Okay, so we call it existing situation where something is undesired. And I'll tell you a story of Kandinsky. Okay, Kandinsky was an artist, okay, an expressionist, and he was not happy at one point of time with impressionism, drawing things by putting little bits of light. He said, no, this is old stuff, I am not happy, I'm just copying other people's work, and came up with a different way of drawing, right? So for him, late impressionism was undesirable, and he came up with a more desirable situation, and it turned out to be German expressionism, right? Like that, we can take similar examples. I'll take a more regular example, which is the problem that many people in this, what we call in the countries of the South face, which is to get access to clean water. Okay, and typically in India, for example, it's about 2 to 5 kilometers from their regular place where they will get clean water. I think this situation is very similar across countries in people who are in a less than desirable economic situation. Okay, so you might say that's not a good idea. It's an undesired situation. They have to go a long distance. They have to carry clothes which are heavy. There are safety issues. Roads are bad, and also water gets spoiled when you clean stuff in the water, right? So how do you do that? Avoid that, and also washing is effort and time consuming. So there are multiple issues, and then you say, okay, fine, I want a more desired situation. For example, can I bring water closer to home? Can I make roads safer? Can I clean things in the water, but water doesn't get spoiled? Can I make it less effort intensive, and so on. So you take your direction and it becomes a desired situation, and then you plan how to change one to the other. And so you come up with a plan and you hope that if you implement that plan, the undesired situation will become more desired situation. And design is a two-meaning word. You can take it as a noun, a design, or as a verb, to design. If you take it as a noun, it's a plan. It's a plan for change. That's as simple as design is. Now, go back to all the examples that I have given, you will see that they're all plans for change. Okay? Only the kind of change that you're interested in are different. But that's okay. And a design is a plan for change, for something of existing situation to a more desired one. And depending on the kind of designer that you are, your name will be different. But you're all planning for change. Okay? And designing, or to design, is how you plan for change. So you have to construct what change you want, that's the goal. And then you have to construct how you want to achieve the goal. Both are part of designing. So you are, if I take the more student analogy, okay, you are a designer, you are both creating your question paper and answering them, right? You have to plan for change. So if you are a technical designer like I am, then you are probably designing a power plant. If you are an educational systems designer like Maria Montessori, you may be designing a Montessori method. If you are an aesthetic systems designer, maybe you are designing a logo or a piece of art or an advertisement. And then if you're a legal systems designer like the politicians, then you are designing laws and so on and so forth. They're all constructing for plans for change. And with that, I will stop because we should eat something. Thank you.
Thank you, Prof. That was really interesting example that you have already mentioned. Yeah, and I believe it is a fundamental material to align our understanding in design before we dive deeper into the main topic today about design research. Yeah. So please refresh yourself with the snack outside this room. Yeah, and you can take the snack inside the room. Yeah, you can take the snack inside the room, and we will continue our talk. Yeah, so please have yourself.
Getting introduced to the color. So that's my book. This is, I primarily use chalk pastel for painting. So this is drawn in chalk pastel. And I am not a professional. My interest is primarily to understand painting, and I think whenever I see a different style of painting, I try to do it myself. This gives me a greater understanding of the kind of style and so on. So I'll just show you a few of those and see. These are sketches, right? So they're just drawings, some of the examples of drawings, more abstract drawings and so on. Then from sketches I moved on to just using pen to draw. I will just show you one example. So this is called ambition. So one is trying to climb the stairs, and I use that as an analog for this, for painting. And then I tried with faces. This is my favorite topic, faces. So here I was experimenting with more geometric lines, with more organic lines, and see whether they can go together or not, where they clash with each other. Very interesting conflicts that get created actually in artistic sense. This is basically flipping the face in multiple directions. So as you do, you know that some of Picasso's paintings try to capture multiple snapshots in one painting. I thought it would be good to see what it becomes if you use it as a single line. This is similar thing, you can see trying to capture multiple scenes. This is basically thumb painting, so you use the color directly to create faces. Then I started working with okay, how few lines can you use to make figures and so on. Very powerful actually. And then various geometric shapes, fewer lines, different types of lines. And then I started getting into more geometric drawings, primarily inspired by Modigliani and other painters. So you can go further. This is a mixing lines more along the lines of commercial art, mixing colors and lines, and so on. I'll move on from that. Then I started experimenting. This is from Picasso. Started experimenting with cubism and getting multiple faces here and even more faces here and further faces here and so on. It started getting more complex, beginning to have some quality, even more of those. These are all pencil sketches. This is face again from multiple directions. I'll skip that and let me show. Eye is one of my favorite topics. I like eye. So I play with eyes, so that's one, the regular one. But then in different media, how does eye change? If I put with against other things, this pencil sketch, then can I use a watercolor kind of, how does eye change as a result and so on. So different expressions of that. Then more abstract writing. So this is the back of the head of a woman with a bun. So just pure ink to create expressions. Multiple faces of a woman, more abstract drawings. This is dream. So the interest is, okay, how does thought get merged with the head as one dreams? Thinking, how does one think? Deep thought, philosophy, and so on. Then more experiment with crayon. That was oil crayon. This is chalk crayon, chalk pastel. This is face. Okay, more faces and so on. And then experimenting with human bodies. So that's various nude forms. Different colors, further expressions. This is playing with multiple bodies. You can see man and woman there. But different, again, more abstract man and woman here, even more abstract man and woman there, and so on. More abstract. And then this is really chalk pastel. This is a pregnant woman, and the back, again chalk pastel, front, chalk pastel. These are more inspired by Matisse. So I wanted to play with few strokes of more bright colors, more expressionist, you might say. That's a, you can see that's a lady lying down, but in a very abstract form. Okay, that's a face. You can see the eyes, right, of a person. That's a pregnant woman, but again inspired by African art and also Matisse. So things are blending together. These are more my sketches, This is a sideways sketch, so we have to see it from the sideways. I'll not bother. Then I started experimenting with background. Can I use background as a part of painting? So if I change the background, how does the painting change? So I was using covers of, you pack the gifts. So these are gift wrappings as the paper. And so some experiments there. This is also gift wrapping. That paper is actually gift wrapping. That's a woman and a child. You can see the child on the top, and so on. And this is experimenting with paper napkin, which absorbs paint. So then it becomes blobby. So how do you use blobbiness as a way of painting? And then more regular sketches. I wanted to play with strokes. So what are the different kinds of strokes you can use, and what are the, so these are some of those, and some of these, and so on. And then how do you get minimalist? This is actually a painting of my mother, who was very fond of reading while during winter when the sun came and warmed her feet. This is my father. And then more faces in pencil. I wanted to just blunt the pencil and see how that changes the quality, artistic quality. This is my daughter sleeping, and my father, and so on. Not important. It's not portrait really. It's more playing with faces. This is my mother getting older, and so on. Okay. This is playing with crayon, chalk pastel. This is actually one of the better ones. So I wanted to see how the colors merge with each other and create the expression. Again, a lot of Matis there. And then sketches, more sketches, and so on. I'll move on. Quickly, you can see a little bit of mixing of Matis and Cubism there. This is my particularly I like to see how I can use various forms of gray and use that for creating textures. So these are all strokes that create that graininess. And this is anger. So again, this is using a single crayon and rolling it. So when you roll the crayon, you get this kind of expression. It's very interesting how the medium changes the aesthetic quality of paintings. This is a face. I think you can see the face, right? That's the nose, this is the eye, this is the face, right? So this is becoming a little abstract. The lady is sitting there, more realistic, but then you can make it more and more abstract by discontinuing the lines, and it gets more and more discontinuous. All of them are a lady sitting with a flowing hair at the back, but it gets more interesting when you start playing with how abstract you can make it. So going further, this is more cubist female form. This is even more cubist female form. That's a typical cubist female form. And then playing with figure and ground. Typically figure is the foreground and ground is the back, but can I mix them and make them part of the same painting? So playing with the importance of figure and ground. So here you see the people are almost less important than the background. So how do you make background a part of the painting? So that's some play with that. This is one person sitting there. That's another person sitting there, and so on. That's a person sitting there. Somebody lying down. So that's just, and then just patches of color. These patches of color are more inspired by Mondrian and others. Yeah, that's another, and so on. So just to give you, and these are landscapes, but not the regular landscapes. I wanted to get to the essence of the landscape rather than the detail. So the idea that sunlight and water are mixing, and the green is mixing, and so on, and how they become more and more blended into a single experience. So these are some of those towards the end. I'll stop there. There are some horses. Horses are also something that I like as a page. This is a more abstract set of horses, and that's probably the end of it. So I'll stop there for just as an entertainment, and then come back to the more the regular stuff now. Okay, so we were here and we talked about what is design. So we talked about design being planning for changing an existing situation to preferred ones. And now I'm going to talk about design research. What is research into design? What is research about design? Okay, but before I do that, take a step back and we talk about what is science or what is research. Research in general as opposed to research in design. Now, when we talk about science or research, and I use these two words interchangeably, it is the systematic study of the phenomena of interest. Okay, some phenomenon that is I'm interested in, and I want to develop new knowledge in that, and I want to study that phenomenon in a systematic manner to do that. And there are four properties or aspects of that knowledge that makes it scientific. One is that it's purposeful, that there is a particular purpose for this knowledge. Either it improves our understanding of the phenomena, or it improves the phenomena themselves. For example, I can understand how ergonomic this chair is, okay, and I can improve how ergonomic this chair would be, right? For example, Professor Berry's work is in making chairs more ergonomic. So that's the second part. So those are the two primary purposes. Second is new, it's not before. So you are creating knowledge that doesn't exist at the moment. Third is that it's generic, that either it applies in multiple situations or it is a building block that you can utilize in multiple situations. Yeah. For example, when people came up with the idea that load carrying doesn't have to be distributed across the wall, it became a piece of knowledge that I can apply not only in a church or in a mosque or in a temple, but everywhere. And that's the generality. So generic is a very important part. And valid. Valid means it's not just my opinion. Okay? It is something that I can externally evaluate and say, yeah, there is a sense of truth in what I'm saying. So purposeful, generic, new, and valid. Please remember those four words. They are important. Now, when we talk about design research, we talk about design phenomena. When we talk about physics research, we talk about physical phenomena. When we talk about chemical research, we talk about chemical phenomena. Talk about biological research, talk about biological phenomena. So in design research, it is. Now the question is, what is this design phenomena? And so this is our take at what a design phenomena is. For that, we know what design is, we discussed that earlier. Now when some designing takes place, it takes place often by people, all kinds of stakeholders. So people are an influence on design phenomena, right? It depends on how I design and you design will be different. So people have an influence. Second is what kind of things we design will influence. The way you design a logo will be different from a design, you design a piece of building or an aircraft. What knowledge you have when you are designing will make a difference. The way people design pyramids when they had no idea of soil mechanics are very different from the way we design high-rise buildings today, right? So knowledge matters. Process, are you using a particular process will change the way you design, right? The economy within which you design will change design, okay? We talk about resource-constrained economies. How do you design for resource-constrained economies? It's very different from how you design the evening gown that will be worn once only in one red carpet event and that's it. They are very different, no? So economy matters. Ecology matters. Do you have the resources? I was listening to a presentation by one of our colleagues here, Bismo, that he's designing this motorbike. Motorbike is for islands where there is no road. So you design that differently. So that's an example of how ecology, for instance, influences. And organization. Are you designing in an organization that is very hierarchical as opposed to very vertical and so on, will change the way you design. So there are multiple influences on design. We call them facets. Designing is planning, we told already, and it is influenced by all of these. And therefore it is multidisciplinary, right? Knowledge from all of these different sciences will be brought to bear to design. So therefore your research can be either to understand this in itself or improve the interface between these. Okay, how do I improve the people aspect of design? How do you improve the product aspect, the knowledge aspect, the organizational aspect, and so on? So depending on that, you are probably going to draw on and adapt work from, let's say, anthropology, ergonomics, psychology, aesthetics, and so on, if you are working at the people aspects. Maybe natural engineering sciences if you are working on physical products. Maybe knowledge management, software engineering if you are in this aspect. Maybe systems engineering for process, economics for these aspects, ecological sciences and management sciences. They're just some examples. This is not exhaustive. Just to give you an idea why we are interdisciplinary and multidisciplinary, right? So therefore, DR Design Research, DR, develops knowledge to inform, practice and education of design or support practice or education of design. And knowledge is about design phenomena, which is about designing and its relationship to its facets. Okay? And is multidisciplinary, therefore the research methods that you use will be drawn from multiple of these facets depending on where you are focusing. Right? That's why you see for people aspects of design, many people will go to ethno-methodology. Ethno-methodology. Okay? These ethno-methodological aspects were invented by people in anthropology because they were looking at tribes to understand the customs of the tribes. And in some sense, design arts are also a tribe. And if you want to understand them, maybe you should take it ethnography as an area of research method. So typically it will be a combination of these. So what is design research? Design research has two kinds of outcomes. One is to improve understanding, so you are developing theories of how designing works, how designing and its relationship to facets work and so on. And the second is to support, to make designing better, right? How to make it better. And focus typically is different from traditional sciences because typically traditional sciences focus on the first one, providing understanding. But we want to understand the present to make it better. Therefore, both understanding and bettering are part of our activities. Okay, so all kinds of outcomes, these are just some of them, theories, models, but also support like guidelines, methods, tools, standards, materials, processes. For example, I was talking to Fa Imam the other day who was on Wood, and he was very excited. He has found a 3-step process by which he could take coir from coconut and turn them into a very strong, say, vessel, bowl. Okay. Now, once you know that, you can use that as a construction material. You can use that as a material for making bowls, but it doesn't have to be a bowl at all. So back to generic. So suddenly you have a generic building block that designers can use and expand its repertoire of materials, right? So that can be one. It can also be technologies like graphical user interface, right? How do I create my user interface? What are the blocks that I put? Pull down menu is one. Somebody invented pull down menu. It didn't come right like that. Like that, there are multiple. Policy building blocks. So it can be all of them as part of forms of knowledge. Now, finally, what is a research methodology? Okay, here I draw on a quote from Werner Heisenberg, who was one great physicist, and he said what you observe, when you observe nature, what you observe is not nature itself, but nature exposed to our method of questioning. So in other words, it depends on what question you ask and how we ask that question as to what answer we are going to get. Right? Very interesting. I'll take a more light-hearted example. Okay, I was talking to a friend of mine, a colleague of mine at MIT, Warren Searing. He was the head of mechanical for many years at MIT. And he said, they did a study. They found that the MIT students are not creative. They looked at their outputs and measured and so on. And they wondered, how can that be? I mean, these are some of the brightest of students. How can they not be creative? So then they gave them some creative problems, and they found they were incredibly creative, no problem. Then they asked the students, why is it that, exams, you are not creative? So the students said, you did not ask any question that requires creativity. Why do you need to be creative? So it is the question that you ask and the way you ask the question that decides on the answer. It's a very important point. And that is what research methodology is. Research is asking questions, and methodology is how you ask that question. Alright? So, what is a design research methodology? It is asking questions and the way of asking questions in terms of design phenomena. Right? So that's design research methodology. So it's a set of research methods and the way they link with each other as a framework for systematically carrying out design research. How do you carry out? You can carry out design research in a very unsystematic manner. What's the problem? The problem is that it will take forever to come up with something that other people will agree with. And therefore it makes sense to be systematic. Okay? And come up with something that can be relatively quickly without spending too much resources to come up with. So just to put these three in perspective, design is what we are trying to improve and understand better. Okay? And we are trying to do that by using design research so that we can help improve them. And we are using design research methodology to help improve design research so that we can help improve design. So it's a long stick. Okay? And so it's a long stick, but a very important one. So we are trying to improve the way a design researcher operates in the last one so that they can come up with tools and methods that can be used by the designer to help improve design. Alright? Okay, I'll take some water. Okay, so what's the goal of design research? Ultimately, we want to support designing. We want to support designing by developing knowledge. Remember, generic, new, valid, and purposeful. In the form of guidelines, methods, and tools to improve the chances of producing a successful solution. Now, there are some loaded words here. One is solution, one is successful, one is improved. So therefore, we can ask some questions. Okay, so and the solution can be anything. It can be goods, services, policies, pieces of art, pieces of architecture, all of them. Okay, 4 questions. One is what is success? What is a successful solution? So what is criterion for success? What are criteria for success? Second is how is a successful solution created? What are the influences on success? Third is how do you improve the chances of being successful? How, in other words, how do you improve the influences so that we are more likely to become successful? And fourth is how do you validate that we have indeed improved it? And those are the basic 4 questions on which our design research methodology is dependent. So please remember this. So what is meant by success? It can be, it will vary from one person to another, one researcher, one activity. If you are working in creativity, you are maybe interested in improving novelty of designs that people are able to create. If you are working in manufacturing, you may want to improve productivity. If you are working in, let's say, environmental architecture, you may be interested in figuring out minimizing resources with which you can create them, or you can reduce the resources with which the space is better utilized, right, like that. And I can go on, right? So they come from all the facets that you have seen. It will be either people facet or product facet or knowledge facet or economy facet or ecology facet or organization facet or and so on, right? So it will be one of those facets. Some property. What influences? Similarly, there will be people facet and so on, right? Something or the other will affect that. How can it be better supported? So here you will develop something, maybe guideline, maybe other knowledge, with which you can create, enhance, reduce, prevent influence of some of those facets. Yeah. For example, if it turns out that when you want to be creative, one of the major problems is that people get fixated. The word fixation has a specific meaning in creativity literature. Fixation means I show you something, you get stuck. Okay, it's difficult to come out of that. So your knowledge can be a block to your being creative. So how do I unfixate you may become a major way, a major support of being creative. So that's a people facet, right? Fixation is a people facet. And will this work? So we need to evaluate the support to see its ability to achieve what it's designed for. So we can put it in a matrix also. We can say, okay, we are developing theories of current way of design happens and evaluate whether they are right. Or we can develop support to improve current ways of design and evaluate support to see whether that happens. So therefore I can divide that into a design research matrix, and I can take these 4 blocks here, this one, this one, this one, this one, as 4 areas in which we have to operate. And so, as I said, generic, new, creative, and valid, and focus on design phenomena. For example, if I look at that, these are the kind of questions we might ask. What is meant by design creativity? What is meant by manufacturability? And so on, right? And then, so we are trying to understand design phenomena here. And then I can change that and go to the next block, okay? And then ask, is it true that this is what is meant by design creativity? So what I did is I took the same question and only changed the front of it. Earlier question was, what is meant by design creativity? I changed it to, is it true that this is what is meant by design creativity? In other words, I'm testing my hypothesis of what is design creativity here, okay? And then all the questions are like that. All of them has, is it true that this is in the front, okay? And then the third one is develop support. So I'll ask this question, how to support X? So how to support design creativity, how to support manufacturability, how to support this, that, and another, okay? And then in the 4th quadrant, I'm going to put, does this support improve design creativity? Does this support improve manufacturability and so on? So you can see that there are 4 variants of the same X, whatever your X is, right? It can be architectural questions, it can be artistic questions, it can be engineering questions, it can be industrial design questions, it can be interior design questions. The fundamental nature of the questions are the same. Okay, what is meant by X? Is it true that this is what is meant by X? How to improve X? Okay, does it improve X? That's it. 4 kinds of questions. Now once you take that and string them together into a systematic process, this is what you get. And this is one of many possible design research methodologies. This is the one that I was part of. This was developed by 3 people, originally 1991. Professor Ken Wallace in Cambridge, no more, my mentor and guru. Professor Lucian Blessing, who is very much there, alive and kicking, and myself. But then, after 1991, we published a paper, 95 we published another paper. Then Lucian and I decided we are going to write a book, and we decided we'll write the book in 3 years, and it took us 15 years. And there was a standing joke that our spouses used to have with each other, Lucian's husband and my wife, when is the book coming out? They were sure that we'll never have the book. Finally came out in 2009. Okay, so this is what you have produced. And you might say that that's very non-productive, such a simple thing. Okay, you have 4 stages. First stage is Research clarification. What does it mean? It means what are the success criteria for your research? What are the problems that you are going to solve in your research? Okay, so this is part of theory development and evaluation. Second is descriptive study. You want to understand what is the current state of the art, what are the influences currently on those success criteria, okay, and how good or bad are they. So they are also part of theory development and evaluation. So you are looking at the existing situation, and then you come up with a prescriptive study. So you go to a doctor and say, I have a problem here. They make a prescription. No, go and buy that medicine and then take it and you will be okay. So this is where we figured out whether there is a problem. Here we are figuring out what medicine we need to give. So that's your support. So this is the support development part, your prescription. And then the drinking of that medicine and seeing whether it works. That's the support evaluation. So clarification, theory development and evaluation. What are you trying to achieve? Okay. What influences those right now and how good or bad are they? Then which of these things are you going to tweak and how are you going to tweak it? And how do you test whether the tweak works or not? And then of course you go through a cycle, because first time nothing works. No design works the first time. If it works, it was a trivial design. So you have to go through some iterations. And so what are the criteria for design success? That is clarification. What is the current design situation? That is descriptive study 1. How to improve? That is prescriptive study. And does the support influence design success as intended is another descriptive study. So in a way, you become a scientist first and understand the situation. Then you become a designer and come up with a prescription. And then you become a scientist again to see whether the design works. So you are a sandwich scientist. Scientist on the top, scientist at the bottom, and a piece of prescription in between. Okay? So these are the stages I have already said. Design clarification is measures of success, influences on success, support, and application. Okay? And then various iterations. And actually, if you then run this and say, okay, then what are the kinds of research that are possible in design? You can nicely categorize into only about 7 kinds of study. I will not get into the detail, you can read the book, but let me spend some time on also showing some methodologies that we have developed. So that's the DRM, the design research methodology. 4 stages: research clarification, descriptive study 1, where you understand what influences success and how well or badly. 3rd is prescriptive study, and the 4th is evaluation, descriptive study 2. I am going to take some examples from our own research to explain those 4 stages and also give you exemplars of some of our design support methods. So these are the 4 questions we ask in creativity research. What is design creativity? So these are the students who worked on them. What influences design creativity? How can design creativity be better supported? And does or will this support work? Okay? You can see that they are absolutely aligned with these 4 questions that we have asked as part of the systematic DRM framework. So, success criteria, what is design creativity? So, Praveen Sarkar asked this question. He started his PhD in 2003, and he wanted to develop a design to support tool for creativity improvement. So he went and looked at, and I asked him, how are you going to measure? How do you know that your tool is going to work? He said, no problem, let me go to the books and find out what I can apply to measure it. He went, he found that there are 200 plus definitions of design creativity. There are 400 plus measures of design creativity, and the difficult part was that it was not clear which of these metrics are connected to which definitions, and there was most of the definitions had not been validated. So we don't have any evidence that they actually work or not. So it was a very difficult situation. So I said, Praveen, go and see whether there is something common across them that can give us an idea of what creativity is and how to measure it. So he did that. So we started working on a common definition, and we asked the question, there was no benchmark to use, so we had to invent our way of figuring that out. So I'm asking this question back to you. If there are two different definitions of something, which one do you pick up? Yeah, the one that?
More sense.
Yeah, but it may not make more sense to people who are going to evaluate my work. Right? Ultimately, it has to make sense to others also. So, what does make more sense is the question. What should make more sense? So anyway, we had no easy answer to that question. It's a difficult question. So we said, okay, let's look at the parameters that people are saying that are involved in design creativity. For example, some definitions say, oh, it has to be novel. Some work says it has to be original. Some say it has to be useful. Some says it has to be valuable. Some says it has to be feasible, and so on, right? So we said, let's pick up those parameters and count the number of times same parameters you mentioned. And we'll take the most frequent ones and create the definition out of it. That's the way democracy works, right? You ask everybody to raise hand and count the numbers and see who is getting the most vote. So that's the majority analysis, we called it. So we found out that two things are getting most votes. One is novelty and the other is value. So we said, okay, creativity is the ability to create something that is novel and valuable. Then we said, we are not happy. This majority thing is not happy. And what happens to minority? They may be equally correct, but we don't know. So we said, no, we want to have a consensus analysis. How do you do that? So we said, let's assume that all the definitions are correct. But then how do they make sense together? So then we said, okay, when you find the parameters, see whether some parameters are more general parameters and other parameters are more specific parameters. Then we can put them under a hierarchy or an umbrella. And then we pick up the highest points of those umbrella and put them together. For example, for something to be valuable, it has to be feasible. If it's not feasible, it's not going to be valuable, right? So feasible is, but valuable is a bigger parameter than feasible only. Just feasible is not enough to be valuable. Something more than feasible is valuable. Therefore, we pick up valuable as a representative for both valuable and feasible. You understand? And so we basically covered everything. All 200 definitions, all parameters related, and came up finally with the same definition. So we are much happier now. So we use this common majority analysis and relationship analysis to look at the most common features and also the most generic features. And then we ask the question, okay, fine. Now that you have a definition of creativity, how do you measure? How do you operationalize that definition? So when you say the word novelty, okay, fine, you might be thinking novelty as different from me. So how do you measure that? So then Prabir looked at a model called Sapphire model. I'll come to explain what Sapphire model is, but basically what he said was that ultimately novelty is about how different something is from what exists, right? How different it is from what exists. It's easy to see whether something is different or same, but it's not easy to see how different, okay? And that is where we have to create a scale of novelty, right? For example, I take a ruler and I can measure how long this table is long. And I can tell whether this table is bigger than that table or the same table, same size and all that. So we need a scale to that. So what is that scale for novelty? So basically that's where we spend time. I will not spend a great deal of time, but let me just tell that we can look at the difference. And for example, something where the function is for the first time is highly novel, first flying machine. But if something is a flying machine, we already know what flying is, and the machine is exactly the same as current machines, then there is no novelty. So something in between has to be figured out. And this is where this model of causality is important. So I'll explain what model of Sapphire model is. This is a very important model that we have found it to be. Okay? So Sapphire stands for, are you able to see it? Yeah. So SAPPHIRE, right? So A stands for state, A stands for action, P stands for part, PH stands for phenomena, okay, and I stands for the I in sapphire, and R stands for organ. Now, what does it mean? Okay, so let's say that, what is this? No, that's not a good idea. This is one mobile phone. So this object has some parts, right? And I've kept it on the table. So this is the part and relationship interface, right? So there is a part, the table, there is a part, the mobile phone, and there is an interface where it is touching each other. And now, because this part has certain properties, these are called organs. For example, it has some weight, and this interface has some friction, right? If I now apply an input, like a force, like this, it will, as a result, Newton's laws of motion will get kicked, and friction laws will get kicked, and this phenomenon of movement will come into place, and this object will change its state from being static, not moving, to moving. And as a result of that, it might end up here. Now, if I'm doing the same thing here, what's your name again? Yeah, so Zenji, G is in Hindi respect, like Fa. And if I'm doing that, this may be interpreted that I'm giving my mobile phone to him to use. So that's action. And as a result, something else might happen. Now instead of that, if a child is here and is pushing it just to play, and at some point, oops, it falls. Right? So what has happened here is that part has changed. The interface between this and this has changed here. And as a result, new organs are created. Okay? For example, there is nothing to support it from the ground, so the gravity is now, the gravitational force has come into play, and this will now, instead of moving sideways, it is moving downwards. Okay? So phenomenon has changed. State is changing, but differently. Not sideways, but going down. And of course, when it touches the ground, at that point, another phenomenon will come into play, and it probably will break. Well, this will not break because they have now tested it and so on, but earlier mobile phones would have broken. So you can see how this really simple expression can lead to a description of how something works, how something changes. And why is this important for me? Okay, I can ask the question, what Praveen did was, he said that if two products are different at action or state change level, as opposed to organ or part level, they are more novel. For example, if you have a way of cleaning, where cleaning is happening using suction, so think of this, you have two different broomsticks. One broomstick is made from one grass, another broomstick is made from another grass. Between these two broomsticks, I can compare novelty and say there's a little bit of difference because part level, they are different. The grass is different. But if I compare a broomstick with a vacuum cleaner, then they are different at the phenomenal level. Because one is using suction, the other is using impact. So therefore they are more novel. One is more novel than the other. If broomstick exists, and I come up with two different variants, one is another broomstick and the other is a vacuum cleaner, then vacuum cleaner will be more novel than broomstick compared to the existing state. That's basically the idea. So with that we did work and come up with a model of creativity. Similarly, usefulness, which is a parameter of value in utility products like vacuum cleaner. He said, well, a product is useful if it's used. Okay? So the more they use, by more the number of people that are using, the more is the effect on each person. If I can aggregate that, it's more useful. One person using one product once in a while is less useful than lots of people using that product all the time and getting benefited heavily. Okay, for example, I am getting my headaches cured with one medicine is less effective or less useful than somebody getting cured from headache for the entire life by taking one medicine, and so on. Okay, I will not get into the detail. I want to give you a trailer rather than the whole movie. Okay, so it's more important to people, it's used by more people, and it has longer effects. And by that he created some equation and all that, and he said, I'm going to multiply these two, and that will give me a value of creativity. Something is more novel and also more useful, it's more creative. Something is only more novel but not so useful, is not that creative, and so on. So, and we have tested that by taking people's experienced designers' views and comparing that with the outcome from this matrix. Okay, so that is testing the theory. Okay, yeah. So moving on, the summary is this: creativity in design occurs through a process where an agent uses its ability to generate ideas, products, or solutions that are novel and useful, but useful only in utility products. The general thing is valuable. Okay, and value, for example, in artistic creations need not be usefulness. It may be how different, for example. Okay, how stunning, how emotionally impactful, and so on. So value will vary from one domain to another. Okay, and all kinds of things affect it. Your knowledge affects it. Your process of creating affects it. Your motivation, very important. This particularly for the students. Okay, if you think that more knowledgeable people are going to be more creative, not necessarily. I told you about fixation. The more knowledge you have, more fixated you become. So creative people, the really creative people, the really very creative people are not only highly knowledgeable but also highly flexible. They don't get stuck to the knowledge. They use knowledge whenever it is needed. They forget knowledge when it is not necessary. And most importantly, you can pick all of them yourself. A lot of people have done that. Have you heard of, I keep forgetting the names. Who invented telephone? Bell, exactly. Alexander Graham Bell, a Scottish engineer scientist, right? Who moved to the US afterwards. So Bell had no idea. Bell had no idea of acoustics. How did he invent telephone? Because his family had a number of deaf people. His mother was deaf. His family had 3 or 4 deaf people. He wanted to give them ability to hear. And he came across a German book by Helmholtz. German books, which means it's written in German, right? He was a Scotsman, so he knew only English. So how would you read the German book? Because now he translated, he learned German himself. Imagine the motivation. He learned German so that he can translate that book, so that he can read that book, so that he can do those experiments, so that he can come up with a device to help his mother. He did all of that. He came up with a translation, he understood, read it, he then started doing experiment. The experiment doesn't work. Tried several years, and he was finally successful. And anyway, I cut the story short, but point is, later on people told him that his translation was wrong. Helmholtz did not do that experiment. He was the first one to have done this. But it's belief that somebody else has done the experiment in the past kept him going, and finally he cracked it himself. But anyway, what I'm trying to say is, especially for students, motivation is the single most important parameter for anything. You can pick up knowledge, all kinds of knowledge, no problem, but you must be motivated. Okay, moving on. So creativity is novelty into usefulness. This actually works. At least for utility products, we have done zillions of experiments. Okay, moving on. So from criteria. So we have found out criteria here. So this was an example of criterion research. The first stage in the DRM. We created an understanding of the criterion of creativity and how to assess this, okay? And then some students started asking, okay, right now what is influenced by creativity? How does designing take place and how does creativity work in there? Okay, so when one of my students, Srinivasan, he said to me, Professor, if you go from here down, it is synthesis. And if you go from here up, it is analysis. Analysis and synthesis. Synthesis means how do I create things that will do some, serve some purpose. And analysis is how do I know whether a given system serves its purpose. So in one case you are going from here to here, how do I get this action, what parts do I need to get this action done? And if I have these parts, will this action get done? Okay, so he started working on that. And here is an example. Now this example is, how many people have done science in their school level? Raise your hand. Even if you have done, you know about electricity, right? How many people don't know about electricity? Raise your hand. Everybody knows about electricity. How many people know that there is this thing called resistance, electrical resistance? Okay, electromagnetic induction. When I put electricity, I can magnetize something, it starts attracting. Okay, very good, then you will understand this. So question here is this. I have a resistance which is connected to a battery through some wires, and when I do that, electricity flows, right? And it gets wasted or utilized. So resistor connected to battery through conductor wires is a system that is given. These are parts. Resistor is a part, connector is a part, battery is a part. And because these parts are there, they have resistance, they have closed circuit, they have constant temperature and all that. Okay, so these are organs. Because these, if I now apply a voltage by using a battery, that's input. If I give that input, because of the organs, something called Ohm's law is utilized. So physical effect. As a result, a phenomenon of conduction of current happens through the circuit. So this phenomenon, and this may be called a change in state. Something that had no current now has current. And this is something you might call generating current in the circuit. Action. So action, state change, phenomena, effect, organ, parts, input, sapphire. Okay, I have explained now how this set of parts will generate current. Okay, now I want to do synthesis. I want to ask the opposite question. How do I generate electrical current? So then you can say, okay, my electrical current is no current to some current, or some current to even more current. Okay, let's say it is no current to some current. Okay, therefore I have to have flow of current as the phenomena. Okay, and how do I get that? Okay, I can use many effects. If I pick one effect, then I have to provide potential difference as an input. I have to provide resistance and so on as properties, organs. Where do I get those organs? Oh, look, I can use a resistance to provide resistance and all that. Or I can go further and say, how do I provide potential difference? Oh, I can use a battery. Or, and I put it together, that becomes my solution. Or, I go further and say, how do I provide potential difference? I can use electromagnetic induction. And how do I provide electromagnetic induction? I can change flux, and I can use this phenomenon, effect, and that requires these properties or organs, and I require this kind of objects to provide that. And now I put it together and I can go on asking that question, and that will create new solutions. So you are seeing that I started earlier with this design, now I am able to come up with new designs, because I am asking the same set of questions but multiple times. Okay, even if you have not understood all of these symbols, it doesn't matter. The most important point to understand here is the sapphire model, that there are seven constructs that are generally applicable to multiple areas of application. We have used sapphire model to model product service systems also. So how does, for example, banking work? We can explain using sapphire model. So it's actually quite powerful. So now, what the student said, Srinivasan said, that when we design something, utility products. So remember, I'm an engineer, right? My primary focus is utility products. So he showed to me that when you ask people to design these utility things, if you record what they are doing and analyze that, all the things that they are doing is either at the action or state change or phenomenon or organ or part level. They are basically asking those kinds of questions, but they are asking them in a different way. So this is the sapphire levels, but they are doing two more things. One is they are asking questions either as questions or answers. Okay, how do I create this action? That's a question, a problem. Or is this a way to create that action? That's a solution. So that's one thing that is added. And second thing that is added, if you want, you can sit there. It's easier to see for you. Go around and sit there. And they are either creating something, a problem or a requirement or a solution, and then they are evaluating, they are modifying, or they are selecting. So they are doing only 4 things there. So in some sense, this is a space of possibilities. I can generate an action level requirement, I can evaluate an input level solution, I can modify a phenomena level requirement, and so on. You understand? This is like a space of possibilities. And every point in this space is a combination of this, something in this, and something in this. And therefore, design, if you can describe the design using a number of activities that people are doing, it will look something like this, a spaghetti in this space. Okay? Where each such point is either here or here or here, 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 here. Okay? And how do we know this is correct? Because we have done multiple studies of people and seen what is happening. Okay? They have found that, for example, these are some of the examples from real design experiments. Now somebody is saying, I want to clean. So we give a problem, please clean the campus from dry leaves. So somebody is stating that I want to keep the campus free from dry leaves. This is not the same as cleaning, okay? Keeping free is not cleaning. Cleaning means it has already become dirty, I clean it. Keeping campus free means it has never become dirty. So he is reformulating the problem. So this is an example of generating a requirement at action level. Okay? Is sweeping okay? Somebody asks. So he is evaluating whether sweeping as a phenomenon is a good solution. So he is evaluating a solution at the phenomenon level, and so on. I will not get into the detail. Okay, so this is descriptive study. Now, why did he do all of that? He wanted to finally see whether people are being creative, and if not, then where is the reason? Okay, so he plotted, when somebody is designing, he plotted how many times they are doing something that is at the action level, state change level, phenomena level, effect level, organ level, and so on. And when they are doing something, how creative is the design at that level? And he found out that when people are operating at action state change level and phenomena level and part level, when they are operating at part level, their novelty is very low. When they are operating at the state change level, the novelty is very high. And when they are operating at phenomenal level, they are somewhere in between. In other words, if we can help them come up with solutions and so on at more action level rather than phenomena or effect level, they will be more creative. So that's the conclusion. I'll skip the maths part because that's not that important. So we have gone through the second stage now. Basically figuring out how things are and whether they are bad or good. The third level is now we have to come up with the medicine. So this is prescriptive study or support development. So we looked at 2 kinds of approach. For those who attended yesterday's talk, was it yesterday? It was yesterday, yeah. Yesterday's talk, we talked about process knowledge and product knowledge. Right? So those are, both of these are support. Examples of support. Okay, we came up with this a framework, and basically it says the following, that you have to develop your requirements at all levels of Sapphire. So generate requirements and actions, state change, phenomena, effect, input, organ, parts, and so on, and evaluate them at all of these levels to make sure that they don't have any contradiction, they are feasible, and modify if necessary, and finally select the good ones. So it ensures that you are not only focusing on some or the other, but all of them. And then once you are happy with your list of requirements, then you make sure that you are operating first at the action level, then at the state change level, and then at the phenomena effect level, and so on. So that once again you go more thoroughly through all the different levels of requirements and solve them. And for product knowledge, we came up with two different ways. So one question we asked here was, people get fixated. Okay, whatever their own knowledge is, they get fixated by that knowledge. So how do you break them free from that? One way that people have suggested is that you show them very different kinds of ideas. So how do you show them different kinds of ideas? We came up with two approaches. One is, can we get a computer, and today is absolutely relevant, but I am talking about my PhD here. This is like 200 years ago. Okay, that was 1987 to 91. At that time, the AI that we had was what was called symbolic AI. Now what we call as AI is statistical AI. They are different. But it is AI nevertheless. Things that human beings are good at, if computer can do it, we call it AI. So I was trying to write a computer program that can generate ideas on its own. And at that time it was considered very novel, because hardly anybody could do that. So we came up with a support called function, which can automatically synthesize designs, in this case mechanical engineering designs, for inspiration. They were meant to be given to people so they could think in different directions rather than get stuck. So here is an example. Okay, if you look at, okay, that doesn't have a latch. This door has no latch. At least I can't see it. Does it have a latch? No. Okay. But you know what a latch is, right? You rotate it, the door disengages, then you pull it, it opens, right? If you look inside, what happens? What allows that to happen? Well, here's an example. This is a door latch. So inside, this is the handle you are rotating. There is a little cam here. That cam rotates like that, and there is a link here. That link gets pulled, and as a result, this wedge, which was inside the frame, gets outside the frame, and therefore, at that point, if you pull it, you will be able to open the door. If you let go, because of some spring on the top, it will go back. This side of the wedge will hit against the frame. There is an angled line there, and it will go inside and then outside again. By that time it is inside a little hole on the frame, so it gets closed. That's how it works. And there are many such designs. What I did was, I looked at what is inside. I opened all these things, I looked at inside. I found out that this element, you are pressing down, it rotates. When I looked at a paper punch, I found that this element, I press down, it rotates. It's similar. So the handle functionally is similar to the top of the paper punch. Then I looked at this called a Scotch yoke mechanism. It's inside your compressor that is inside your refrigerator. I found out that this element here does exactly the opposite of that. I rotate and it moves at the outside. So potentially I could find things like this one goes back and forth, this one that goes back and forth, these two punches go back and forth, and so I could find out a number of ways in which things move. And I abstracted that. What did I find? I found only 5 elements. These are the 5 elements. One thing that goes back and forth, like this. One thing that one side goes back and forth, the other one goes back and forth this way. Okay? This goes back and forth this way, this goes back and forth this way. This one does like that. And this one goes in 3 different axes, X, Y, Z. Now, if you take a wedge, it goes back and forth this way on that surface. that surface goes back and forth that way. Okay, so why am I saying all of that? What I'm trying to show you is that when you looked at this level, it was really complex and different. No. Now, because of this abstraction, all of this can be now described using just 5 things. They are not that different. And I'll show you how. Let's say I want to press down here and want something to retract here. I can take some of those elements and connect them together and create something like this stick diagram. And if I flesh it out, it will look like this. So here, this hand is represented using this lever, and this cam is represented using this element, and this object is represented using the combination of these two. Okay. Now, this is okay. This is just a representation. This is the magic part. I can take a bunch of other components of those 5 only, put it differently, and look what has been created. There is a handle here, I press it down. There is a wedge here that goes down. Because of this slanted edge, it also goes inside, and therefore this object goes inside. It's a different way of doing that same function as existed. This is new. It's created by the computer. I could have patented it at that time. Now, in one, I know that there are multiple microwaves where this design is used. Independently of me, I did not take a patent. But that would have been one of the first patents that generated from a computer. And then a PhD student of mine, a very bright Taiwanese student called Richard Liu, he said, "Professor, I can do better." I said, "I'm sure you do." And he said, "I'm just going to change one element in this design. Instead of using that single wedge that I showed you, I'm going to use a 2-element wedge like this, or a seesaw." This is the most interesting one. If I take how many people have used a seesaw? Seesaw? Everybody has? Yes. So you know. Then you understand this solution. So if I have a seesaw and I move it this way, this side rotates, right? I can only take this side movement. So it will appear that it is working like a wedge. So I can use that as another possible solution. So what I am showing you now is that by simple combination of appropriately abstract elements, I can create very different designs. And we created a tool afterwards. Ujjwal Pal created a tool where you can express all of that, and in minutes you can create hundreds of different designs. This is 35 years before generative AI. Gen AI. Okay, a very different approach is this one. This is the last bit. A very different approach is this one. This is called Idea-Inspire. Idea-Inspire is the world's first biomimetic inspiration tool as early as 2005. What we do is use the Sapphire model, action, input, phenomena, organ, effect, parts, and state change, to describe how biological and non-biological systems work. For example, how does Venus flytrap traps an insect? Okay? Or how does a friction disk is used for changing speed in an object, and so on. Okay? But that's the point, is that it's a glorified database of how things work. And when you have a particular problem, let's say I want to climb wall, what are the different ways I can climb wall? It will tell you, oh, you can climb like a spider does, or you can climb like a gecko does, or you can climb like a dust particle does, and so on. And you can figure out how it does so, and hopefully you'll get inspired by that. So we did an experiment. How do you know? So this is your prescriptive study. The third stage of DRM, support development. The fourth stage and final stage is to figure out whether the support works or not. So how do we know that that combination, right, with all these abstract elements putting together, giving it to designer actually makes any difference? So here is the study. Okay, so we took 3 different designers, okay, and asked gave them a problem P1 and asked them to come up with as many designs as possible on their own. And after they exhausted, we taught to them function, that tool, and said, okay, get inspired by this and come up with new designs. For another problem, because the same problem cannot be given. They are already influenced by the earlier problem. So, and then for the other group, we gave problem P2 to solve without idea function, and then gave them P1 to solve with function. All the solutions created using function are deep blue. All the solutions created without function is light blue. What did we find? We found that irrespective of which team was solving which problem, whenever they used function, their number of ideas went up by multiple. Okay? And this is in terms of creativity called fluency. So they were highly fluent when they were using function, much more so than when they were not using function. Okay? And that is irrespective of the problem. Some solve P1 first, others solve P2 first. And yet, in both the cases, function-induced designs were many more. And it is already shown in literature that more fluency leads to more creativity and so on. So you can conclude that people are likely to be more creative if they use function, as opposed to not. So this is an example of how do you evaluate the support to see whether it works. So fourth stage of DRM. Here is an example of using Idea Inspire. I talked a little bit yesterday about them, so some of you are from there, but here you will see more detail. For those who are not there, of course, is okay. So first we use that Gems of Sapphire to create the requirements. And for example, we are talking about a lunar vehicle design, a design of a vehicle that will move on the lunar surface. This was a project that was given by the Indian Space Agency, ISRO. So we first created the list of requirements. For example, the mass of the vehicle should be 10 kg. So that's an organ, because it's a property, right? Mass of the payload is an organ, size is an organ, speed is a phenomenon or an input. Launch and land load is 40 g, that is 40 times gravitational acceleration. Okay, so that's an input and a phenomenon. It has to handle gradient up to 30 degrees and minus 30 degrees. So that's an action, an organ. And like that we have categorized the requirements. So requirements are also in those sapphire levels. And then we decided that we are going to basically look at it as 5 functions, 5 actions. One is mobility, accelerate, decelerate, steering, left, right, handle gradient, up, down, climb and avoid obstacle, stability, don't topple and so on, and prevent from environment. The lunar surface can get very hot, like plus 80-90 degrees, and very cold, minus 80-90 degrees. It has to survive that. Anyway, I'll quickly, I'll not get into all the details, but these are some of the mobility solutions that are inspired using Idea Inspire, some from motors and some from magnetic wheels and so on. But also I'll show that, also from gecko lizard. So this is designed by inspiration from gecko lizard and so on. Yeah, many ideas, I'll not spend much time, but many of them are artificially inspired, many of them are biologically inspired. And finally, and this is interesting, stability and protection from temperature and all that. Finally, and I mentioned it yesterday, this is a children's buggy, right? You want to carry a baby, then you do that. And this is a spider-inspired concept, I think. These two are married together to create one design, one final design. So both artificial and biological came together. I'm not sure if this is going to run or not. I think it's not going to run. But if it did run, what you would have seen is that this design, the payload is here, okay, in this carriage. And when it sees an obstacle, it lifts it and goes over it. It creates a space, right? If it's too big, it will go around it. If it's too small, it will lift it up and go over it. That's one design. And then the other design is, okay, so that's the design, okay? And this is the other design where Let's see where the other design is. Anyway, it's somewhere there. How did we test it? Okay, what we did was, we did a similar study for using IDEA Inspire. We asked 3 different designers to come up with ideas for a solar antenna. Come up with new designs for solar antenna. They came up with 3 different designers. One came up with 9, one 6, one 8. Not all designers are equally competent, so there will be variation in that also. And then we asked them, okay, how many of these designs are actually workable, feasible designs? So 4, 4, 3. And then we introduced IDEA Inspire, say now get inspired by IDEA Inspire. This designer came up with 17 ideas. These are all different from these ideas. This designer came up with 18 ideas. This designer came up with additional 5 ideas. You can see that these 2 are far more creative than this designer. And I know who they are, I cannot mention. They have both become big professors in some creativity aspects. So they are actually working. I can track their trajectory also, and I can see this difference. But that I'm not going to mention. But what you see is the following, that and these are the number of ideas they thought were feasible, because many of the biologically inspired ideas are very difficult to implement. So they have to discard that. You still get an average of 165% additional ideas. So once again, fluency increases by this. So just to tell you that when you ask the question, oh, by the way, these are the 7 variants of design research. Okay, just increasing your interest, later on you go and read about them. And it turns out that the first research that I showed you, what is design creativity, it is this kind of design research, where you figure out by research clarification and descriptive study in a comprehensive way your own work, the criteria. And the last research that I showed you, how effective is function, is here. You are doing a comprehensive evaluation, descriptive study too. So you can categorize. We have done entire conference, all papers are categorized using these 7, and you could not find anything other than these 7 types of research. So that's a validation of DRM itself. With that, I will stop, and thank you for your attention.
Okay, thank you, Prof. And let me summarize the talks today. So, please have a seat, sir.
Sure.
So, in the second session, Professor Chakrabarti already mentioned about 4 stages in the design research methodology. The first one is research clarification and descriptive study, and the next is prescriptive study, and the last is descriptive study to evaluate. Yeah, so there are 4 stages in design research methodology. And Professor is already also provide example, deep explanation about example in his research about design creativity. So if any of you have questions about research methodology, and maybe you can connect it to the research project that you already working on, you can ask the professor. Yeah, you can either raise your hands or you can fill the form that already available. The link is already available in Slido. Yeah. So any of you maybe have question and you want to ask directly? Oh yeah, please, Pak Denny.
Yeah. The last slides were heavy for us. Yeah.
Which ones?
Probably the few slides at the end, because we have to follow some more structures, I guess. But that is not the thing that I want to ask more on. Probably this is not a question, just for confirmation, that if all of you knew that Prof. Chakrabarti has developed the Spira model for 2 decades ago, I guess. Ya, mungkin tahun 90-an ya. The Sapphire model has attracted many scholars in design creativity because it is the way how we evaluate, how to measure the novelty. Yeah. Of course, banyak ya, quite many of methodology to measure the novelty or the creativity itself. But the Sapphire model is interesting because not too complicated to measure. That's what I think of. Sapphire model, as Prof. Chakrabarti mentioned, can be implemented in any ways of design research. For example, yesterday we had a discussion with doctoral students, and then the architecture student asking about whether the methodology could be applied for architecture design research. So it is possible, right? I just want to confirm that at the beginning of the slides, you mentioned that design research is about observing the phenomenon. When Prof. Chakrabarti mentioned that biological research, where we observe the phenomenon of biology. So design research is pretty much similar, right? Then, just want to confirm, I remember the Koslin theory, if I'm not mistaken. It's about the heuristic procedure of understanding behavior or also the process. Just like structuring, when you mention putting something on top of the table and then you move it and then fall down, it is a heuristic model of understanding a phenomenon. If any of you are attending my class of cognitive design cognition, you probably remember the Koslin theory. So, just want to confirm once again that for any of us, as a young design researcher, we can create our own model, right? We can start using our own idea to evaluate, to analyze, to observe something. That's practically the basic idea. Is that correct? The heuristic model is a basic model how we understand the phenomenon.
Okay,
that's the thing.
Okay,
Thank you.
thank you for your question. First of all, let me just reiterate about the research and design research and link it to other scientific research. I said that research or science is a general term that applies to systematic study, not necessarily only observing, but systematic study of phenomena of interest, so that we can develop knowledge that is purposeful, new, generic and valid. Okay? So observation is one part of that study. There are other parts like development of support is another part and so on. But they are all studies, they are all systematic studies. So that is number one. And particularly for design research, there are two goals. One is the goal to inform. There we observe in order to understand things as they are. Second is we develop support to change the phenomenon or to improve the phenomenon, and this is where we develop support. So theory to understand and support to improve. So two kinds of outputs. Typically in science they observe and develop theories, but in design some of us will only develop theories. I'm not talking about an individual, I'm talking about the discipline as a whole. There are two broad major goals that are connected to each other. One is to develop understanding and the other is to develop support. Develop understanding in terms of theories and models and guidelines, theories and models, and develop tool in terms of support, in terms of guidelines and methods and tools and so on, policies, standards and so on. So that's the first thing. Second thing is that Sapphire model is one of many possible models for doing stuff. Okay, what is a model? A model is a representation of some aspect of reality. Okay, and it depends on what reality you are interested in and what aspects you want to represent, and for what purpose. Why do you want to represent it? So models are typically limited representations of reality. Okay. Now, my intent for developing Sapphire model was originally to represent how something works in a more colloquial manner rather than using equations, so that you can utilize that richer but less mathematical knowledge, body of knowledge, to inspire people using things like idea inspire. It turns out that people use that now for many other applications. For example, Pratt & Whitney, which is a aircraft manufacturing company, used Sapphire model to structure its in-flight aircraft maintenance manuals. Not my work. Some French professors have worked on that in Canada. Rolls-Royce uses this for its aircraft manufacturing knowledge structuring. Once again, not my work, done by professors in Cambridge and other places. Some of my own students have developed measures of novelty using Sapphire model. Other students have developed models of designing using Sapphire model. Other people have worked on developing, Italians actually, they worked on, they wanted to represent a product service system, and they use Sapphire model as the basis for that. So it turns out that it is more than a heuristic. Because heuristic is something that may or may not work. But it seems that for across multiple applications, it does work. So therefore, it's a little bit more than that. But my general answer to your question is, you see what you want to represent, of what reality and for what purpose, and first look at the literature of what exists. If it's already there and you can use it, don't waste your time. You develop new models only if it's necessary. And that is where we got stuck, because we did not find an appropriate model to use when we were looking for one. But there are lots of models, ABS model, for example, from John Giro and others. There are SBF model from Ashok Goel and various others. And many other models are there. First look at them and see if you can use them. Then you can directly go to your particular intent and work on that. So that's my long answer to his question. Thank you. They have already typed some questions, no?
Yeah. They
So
already for question.
So can we look at those questions already?
Before we go to the Slido, is there any of you want to ask question? You can raise your hand. No? Okay, then let me read the question. The first question is from myself, Prof. In many cases, academic versus practical research sometimes focus on different goals, sometimes focus on different things. So how do you see the relationship between those academical versus practical research?
So give me one example of academic goal and one example of practical goal.
I think in my point of view, academical is maybe the goal is more theoretical, to form a theory, and the academical goal is more, maybe it's related to what you said before, understanding and supporting. I think academical is more understanding purpose, and theoretical is more in supporting purpose.
Okay. I think by now, at least in some parts of design methodology research, both of them are accepted as academic goals. It's not practical versus academic. It is understood that our academic goals must also have a practical end to them. So both understanding as is and supporting as should be are both academic goals in design research, and they are both connected, typically will be connected to some practical end. Either practical end as in how do you improve designing, or how to improve design education. That is also very important. This is not only designing, it's also educating in designing. That's also a practical goal.
So, what's different about design research is the goal? Yeah, maybe compared to what.
So it has both academic, academically worthwhile means people, your work will improve what academics are able to do today to improve their ideas. And practical is about how it will change your practice or education.
Okay. So about the context, different context. Okay.
Yes.
Okay.
Yes.
Yeah. Okay.
So that's your question. What are the other questions?
So another one is from Friska. Is there a research approach that support practice-based design research for understanding client habits and spatial needs?
Yeah, so I think the area of practice-based research is still evolving, and primarily for 2 or 3 reasons. One is that normally the way I'm talking in the context of PhD. Normally we discussed this yesterday, but for others also I'm repeating it, that PhD research PhD research is an academic goal. The goal is to create a certain volume of new knowledge, new generic, practical, valid and purposeful knowledge that allows you to get that degree. Now, first question is, can practice-based research be used for that? The answer is yes and no. Some practice-based research will not be counted as academic PhD research, others may be counted. And yesterday, I think, or day before yesterday, when we were walking around, I showed a couple of examples where it has the potential. For instance, some people are working with bamboo and they created a joint. Okay, that joint is such that you can put 90 degrees or parallel connection between 2 walls. Yeah, in that way. Now, if that joint is new, it's not copied from somewhere else, but it's new, and whether it came out of practice-based research or otherwise doesn't matter. If it's new with respect to the current existing research, and it is generic because that basic idea can be utilized across domains, then that can be a building block for new design and so on. And yes, that can be. So I think this question of practice-based versus non-practice-based is not the moot point. The moot point is it novel and is it impact, is it good? Remember, we talked about originality and quality. So it has to satisfy that, whatever the origin of the work. Okay? Next question.
Is that answering your question? Yeah, okay. Oh yeah.
Sure.
Please.
Please use this.
Thank you, Chakrabarti ji.
Yeah.
Yeah.
Thank you. Thank you for.
Yeah. Thank you for your patient lecture, because in the end of your lecture, it's make me, my head is overhead. It's getting hot because you make example like the technical, like the electrical current and etc. But in my chaos thinking, that I see the purpose of like your illustration from the lady of India, how to carry the water, and it's make me getting clear, yeah. Because I face several challenge when I do my research. As you know, that my title of my research is the circular design with wood culture, because I'm from Spira, to empower the small-scale furniture industries. And in this case, I also have my promoter, and my promoter suggested it could be like the practical output, because it's correlating with the industrial symbiosis of Spira. And I think it's useful, because I can use for example, like how to map, how to identify the player of the industry player. I design like the apps piece web, but it's not the outcome from my research, but it's kind of like how to mapping the symbiosis between the player to create the model of the circular design based wood culture. It is okay, because when I see your step in this design from the criteria, then descriptive one, continue to prescriptive one, and the descriptive two. I think it's maybe it's not connected there. I want to give some suggestion or insight how to make my plan for research and get a goal to make a framework of the circular design based wood culture. Thank you.
Okay, so that's a comment, right? There is no question. What is the question? Can you repeat the question?
Yeah, the question is, it is okay, I mean, it is possible when we combine between the practical output with the academic output.
Yeah, okay. See, at the end of the day, for a PhD, practical output or not doesn't matter. Okay, it might be very useful for your promoters, and that's perfectly fine. If you are doing a PhD, the only thing that matters is, has it advanced the knowledge in this particular academic community with your input? Has it become more rich in its knowledge? See, there are many ways of getting credit for getting new knowledge. One is getting a patent, right? One is getting a design registration. One is creating a company and making money, right? All of them are various ways of remunerating people for creating knowledge. The question that you are asking in this particular context is, what kind of new knowledge is worth getting a PhD on? And my point, and I mentioned that from the first day we had meeting with the deans, that not all knowledge are worth getting PhD on. Just because you are doing some new knowledge doesn't mean you have become eligible for getting a PhD. Only certain kinds of new knowledge will fetch you a PhD. They have to be purposeful, new, that applies to every knowledge that you get. It has to be significantly new from what exists. That is number one. And two, it has to have some generic value. And it has to be valid. Valid as in, there is some sense of truth beyond your own opinion or your own conviction. So the question is, where is your contribution? What is your new knowledge in your thesis? Does it enrich circularity? Is there a new way of assessing circularity, improving circularity that other people can use in other contexts, rather than you solve one problem, that's it? This is the moot question that you need to ask in your thesis. It's not good enough to solve a complex design problem and get a PhD. You will get a patent. You might get a lot of money because you have created a company that goes and solves people's problems. That's not a PhD problem. A PhD problem is one that has a generic value and it has a significant originality compared to what is already done in that area that you are trying to enrich further with your new knowledge. I hope that answers your question. Okay. Are there any other question that you want to?
Yeah, this question also maybe can be the reflection for my doctoral fellows. Maybe some of you still confused about what are you doing now and what is your purpose. So maybe you can reflect it. So the main idea that Professor Chakrabarti already said is that we have to create new knowledge, and it have to be valuable, at least for the area or for the community or for the domain that we are working on. Yeah. So is it new knowledge, and is it valuable? Yeah, new and valuable.
And generic.
And generic. Okay, then. So the third question is from my fellows over there, Mbak Adita. What is the best way to differentiate and choose between methods and tools in research design?
What is the best way, the first part? What is the best way to?
What is the best way to differentiate?
I can see.
Yeah. Sorry. The best way to differentiate.
Oh, differentiate and choose
choose
between methods and tools in research design. Okay. Okay. It's too generic a question to answer, too general a question to answer, but about research design, you will be guided by your question. Okay, so don't try to fit the hammer to the tool. Okay, so what is your question? So as I showed you there are 4 kinds of questions, right? One kind of question is about criteria. One kind of questions are about influences. Okay, one kind of question is about support. The one kind of question is about evaluation. So what kind of question are you asking, and in what context? Look at who asked the question. You asked the question. Yes. So look at literature where similar questions are asked and how they have been answered. So don't get too worried about methods and tools. I'm using the word method. In your case, methods and tools are the same thing. They are both research methods and research tools, right? Like a statistical tool for analysis. Have I understood your question correctly? Okay. So what I'm saying is that for the question that you are asking, go to literature, look for literature on who asked these kinds of questions and what kind of methods and tools they have used, and see if it makes sense to apply that in your context also. I want to also hasten to explain that DRM is not a method, it's a methodology. It's a systematic framework of thinking about your entire research. But for each of those questions that you are going to ask, whether it's a DS1 question or PS question or DS2 question, you will have to go and choose different research methods to answer them. Understood? Yes? Okay.
Yeah, okay. So
we can discuss further if you want. Yeah.
Yeah. Okay, so the next is
How can we determine
the most appropriate research methodology for our study when we often felt uncertain during the research process?
Yes. So one way to do that is first to read about what are the research methodologies, and then ask the question which one fits your kind of research better. There are multiple methods. I mean, action research is one. DRM is another. I would say that your primary guide has to be your supervisor. Okay, primary guide has to be your supervisor, PhD supervisor, who I'm assuming is helping you work in an area that he or she has already worked, and therefore knows what kind of research methodologies. Please remember, who asked the question? Can you please raise your hand?
Anonymous. anonymous.
Anonymous, okay.
Is that, yeah?
Is an anonymous person, can an anonymous person raise hand? No, it helps me because then I can ask some question to understand the question better.
Silakan mengaku yang nanya.
Yeah, okay, no problem. Once again I will say, if you are using the word research methodology to mean research method, then there is a problem. Let me give you an example. I can study a human behavior like process by using something called a video protocol analysis. Yeah, video protocol analysis, okay? Now, this is a research method. If you want to analyze a conversation, a human mediated design process, you can record that and analyze it. It is not a research methodology. Research methodology is where you are trying to work out your entire research, all the questions that you need to answer and all the steps that you need to figure out, broad steps you need to do to answer them. So DRM is not telling you that you should go now and use a video protocol to do your study. We are agnostic to that. You can use a qualitative method, quantitative method, mixed method. There are multiple qualitative, quantitative, mixed methods and so on. That question has to be answered separately. There is a chapter on that in the book that you have to read to understand that. But so please remember that. What is the next question? I'm wondering if the Sapphire model can be applied for research in the field of media design or interactive design, and have you observed any example of it? No, we have not. So the answer is I don't know. But if you want to try, please do. I don't have an example right now.
So it is possible to be applicable in media design research?
I do not know. It depends on what parameters they are interested in and whether the modeling parameters are appropriate for them. So they need to try that. I cannot answer yes or no. What's the next question? If the facet design has such a wide spectrum from people to ecology, how do you define the boundary of design research itself? At what point does it stop being design? Okay, very good question. It doesn't. Design is a very generic term. Where is ending? I can't see. Oh, there. Yeah, so it doesn't. There are different kinds of designs. That's why I showed at the beginning different kinds of designers. They are very different looking. They problem very different solve. They solve very different problems. But there is an underlying unity in them, which that definition of design gives. So it doesn't stop being design. It's just that the nitty-gritty of doing research into that becomes different. But I believe DRM still applies. But the research methods that you use will be different. Even if you ask the question of how do people design, as opposed to how does product knowledge influence design, the research method will be different, but the methodology will remain the same. So you will still have a criteria influences support and evaluation. But the kind of criteria, the kind of influences, the kind of support, the kind of evaluation will be different. Okay, does it answer your question? Okay, next one. Isn't DRM always behind the phenomenon it captures, especially with AI reshaping design thinking? How do you study a moving target with a static method? Very good, good, I love it. DRM and the phenomenon, I think there is a confusion here. DRM is not behind the phenomenon it captures. Okay, so let me interpret this. So what I am understanding is that if the phenomenon is changing, how do I understand that using a method? Is that a reasonable interpretation of your question? Whoever has asked it?
Ya, Pak Camat silahkan mengaku.
Yeah.
Yes, I think how can we research something that still moving when I'm a designer? I'm a designer and also a researcher. How can I do a research there? Still moving when I already finished my research, like having my methodology finished, and then the condition is right now AI is also moving and change the thought that the designer itself.
If the phenomenon has changed by the time you have observed it, then there is no general answer to your question. That is true for every phenomenon. If the phenomenon is not there, okay, then what have you observed? You have observed a previous version of the phenomenon, right?
How can we create a methodology?
Please use the mic. Others should listen.
How can we create a methodology that can be applied to phenomenon that move fast?
So let me change your question from move fast to say it changes. Okay? So I am observing phenomenon X. By the time I have finished observing, it has become phenomenon Y. Then my knowledge of phenomenon X doesn't apply to phenomenon Y. So there can be no scientific methodology that can observe it. Because every scientific methodology to observe X makes the assumption that X remains X. If it's not a stable phenomenon, you are not going to be able to observe it. Okay, alright? So there is nothing called moving method. You cannot move the method also. Okay, method is static. And phenomenon has to be static as well. If the phenomenon is not stable, there is no phenomenon. There is nothing to observe because it's not there anymore. You understand? I want to observe a planet which is burning. By the time you finish observing, the planet has gone. It has become energy. What's the point in me observing it? What am I going to do with that knowledge? It's gone. Unless your knowledge is about how does a planet become burnt into energy, then you can observe that. How does design thinking become mediated by AI to become AI mediated design thinking? If that's the observation, you change your time window. Then your phenomenon is not design thinking. It is the evolution of design thinking with AI. Then you can observe that. But it must be there for it to be observed. If you say it doesn't exist, then there is nothing to observe. Okay? So either it's a question or a non-question. There is not both. Either it's a question that exists or it doesn't exist. It cannot be like quantum mechanics. It both exists and doesn't exist. Alright? It's a complex answer to a complex question. Next question. Isn't DRM always behind the phenomenon it captures? Isn't that the same question? It's the same question. Go down. Yeah.
That's the last question.
Okay.
Yeah.
Last question, I survived. Alright, so is there any other question other than those questions?
Yeah. Is there any other question?
No? Pin drop silence. In that case, I'll thank you profusely for bearing with me. And let's close the session. Thank you.
Thank you, Professor. Please give him a warm applause. Thank you for the insightful presentation and engaging discussion today, Prof. We hope today's discussion has provided valuable perspective and inspiration for our research journey in design and design research methodology. Is there anything you want